So let's say that you were on transport and you were going to undo this, right? There should be a circuit and a pressure hose in here that will allow you to hook this up to that E cylinder as a secondary source. So you'd literally come here, grab your pressure hose. This is what the circuit looks like in the package, okay? This is the valving mechanism that we're going to hook directly to the patient, okay? This needs to be powered and measured, okay? This is the pressure connection, right? I do nothing more than come here and screw this in. So you're taking the green pressure line, that is what will accept wall pressure or pressure from E cylinder. Everything is called a hand-tight fit until it's nice and tight. Okay, and then I do the same with the E cylinder, right? I notice that I've got a red and a white line. I notice that the red line's got a filter. This is to protect the ventilator from getting water in it. So I'm going to connect this red to red, which is going to be right here. Okay, and then there's a clear one. I'm going to go clear to clear. And then I'm going to come back to this strange valving mechanism, almost like an exhalation valve. I'm going to look for red to red and white to white. And then I go to the test lung, okay? A lot of times we put on what's called this OmniFlex, which allows a little bit of flexibility with the ET tube and some jostling around during transport. There's nothing wrong with going directly to the ET tube if you wanted. This is just a little bit of a safety measure. Oh, and another thing. So we are not perfectly set up to go today. If we needed a transport, we would be close, but we would not be perfectly set up. Because this is a valve that entrains flow, right? We know that it entrains flow to enhance flow to become accelerated. Well, guess what? This is 100% oxygen going here, but what is it entraining? Room air. So the way this sits, right now you're getting about 75% FiO2 to the patient. So you just need to get a little reservoir that we put right here to guarantee 100%. Fits between these two. This is a fluidics device. Okay. So there is no electronics in this device. There are valving mechanisms that we're going to turn on gas source to by turning this on, by increasing this until we get a working pressure about 40 psi. All my readings are on this electronic multimeter. It is actually powered by batteries, right? It's a feature that we like on transport, is that there is nothing electric that we have to plug into, okay? So all my readings would be there. We're going to turn operational pressure up to around 35 to 40. In fact, you're going to set it at 40 for these adult transports. Operational pressure helps deliver the amount of flow. So go ahead and turn our operational pressure up to 40.
So first thing we're always going to do is turn the oxygen on so that this actually works.
Do a little bit more. Yeah. And it's plus or minus 2 or 4 above 40, 42 or so. With the Bronchotron, we have a digital manometer that shows both the inspiratory flow, which is called Pulsatile Flow, analogous to a PEEP, which in this case is about 25, and it shows the expiratory flow, which is analogous to a PEEP, which is about 9, and the big number is a mean area pressure of 19. So we're going to get a PEEP, a PEEP, and a MAP. We know these are not the exact, but we start with these parameters, okay? I also get the high frequency rate reading, which right now is at 600. This would be like in real life. Let's say that we had a patient in pressure control and they were generating a mean airway of 25. You would try to get close to that mean airway of 25. So maybe let's shoot for 30 over 14 and see where we get, okay? And it's weird, it takes 5 or 6 cranks, yeah. Yeah.
Right now I'm seeing 27, so mean airway pressure about 20.
So we're not enough, so we're gonna adjust both This is the expiratory pressure. We're going to try to get that lower number to 14. So we're going to increase that.
Hold on, is this the one that goes the other way?
Yep.
So now wait till it goes down, now we're still at 11.
You're getting there. 12, 13. I would try that, and now, yeah, and when I look for settings, I look plus or minus 1.
Perfect.
Nice. And let's do a Pulsatile Flow or PEEP of 30, which is the other green adjustment.
Sorry.
Yep.
And right now it's at 29. Wait. 31?
Perfect.
What do you think?
Perfect.
The CO2 is extremely high and the pH is low and the patient's unstable. We want to blow off more CO2.
Okay. We're going to increase the pulsatile flow, and we are going to increase it in steps of 2 to 4 centimeters. 80% of the time, we're going to make our adjustments with either pulsatile flow or oscillatory CPAP. So I'm either going to make my adjustments with either PIP or PEEP. That's pretty straightforward. But if you are in pressure control, and I told you that the CO2 is 85 and that was too high, and then I told you we were going to increase the pressure control PIP by 2 to 4, that would make sense, right? Same with PEEP. If the oxygenation is poor and the chest x-ray looks underexpanded to you, and I told you we were going to increase PEEP for oxygenation, that would make sense too. So we know that this is not a PIP and a PEEP, but when I put these two terms to these inspiratory and expiratory amplitudal waveforms, it makes much better sense. So we'll give it a second to settle, but we're going to ask ourselves a question. What's the high frequency rate about right now?
581.
All right, so let's say that we wanted that high frequency rate to be higher. Let's say that we wanted it to be 700. Dr. Nones, why don't you go ahead and increase it? Now, this guy is a strange vent in that I increase to the left.
Yeah, I do increase.
Right, and I wait for a second. I take a small and I just wait.
700?
There you go, 700. Let's say that we're struggling with CO2 removal and we wanted to be at 500. Go ahead and decrease this to 500. I'm going to make an adjustment and I'm going to wait 2 or 3 cycles. So let's review. Pulsatile flow equals inspiratory flow equals PIP.
Peak pressure.
Oscillatory CPAP equals PEEP equals expiratory flow. Okay. So I have 2 spots to adjust PEEP. I always want to have some flow going here, but for my bigger PEEPs above 14, I create the rest of it here. And I can create 30 of PEEP, whatever I want to create, okay? When I go to another hospital and plug it into the wall, they usually have perfect 50 PSI, right? So the machine will be working the very best when it's plugged into the hospital. As soon as you plug it into an E-cylinder, no matter whose E-cylinder it is, I'm going to check my settings and expect a drop in the settings whenever I go from wall to E-cylinder in general at other hospitals. Oh, by the way, when you go to the ambulance, what do you think can happen? It could change. It could go up. So every time you switch the gas source with this device, you want to recheck your settings. Remember, I said that this device, I love it because I can carry it, right? I can either have it on the patient's bed if there's room, and there won't be because it's ECMO stuff, or I can carry it. And a lot of times, I'll be honest, I involve the RTs at the other institution because they want to be involved, so I have them carry it. I have them carry an extra E-cylinder with me, right? How long do you think it's going to take to get to the ambulance? Well, you know, we got to go here. Do you mind if you carry an E-cylinder along so I have one spare, right? And how long do you get in an E-cylinder? How much time?
23 minutes.
And not a second more.